Hello, this is Gary Marr from Glenrock Community College. This screen capture is for my CIS150AB students, and in this screen capture I wanted to provide a review for Quiz4 and also the final exam. Now Quiz4 will be due on Sunday the 13th and the final will be due during final exam week. All the dates should be in Canvas, and also what I've done in Canvas is for both the quiz and the final I've basically taken away any time limitations. So you can take as long as you want, although it shouldn't take you that long for the quiz, a little bit longer for the final. Too much time is sometimes a curse because you can start reading too much into questions. In both cases, the test and quiz must be completed in one Canvas session. Now Quiz 4 is on sections 9 and 10 in the textbook, which means it's primarily on exception and event handling from Chapter 9, and then GUI processing from Chapter 10. Now you want to include the readings, the lectures, the assignments. It's open book, open note. I wouldn't search the internet. It's probably not going to help you. What I would do is in advance of the quiz and the final, I would look through all the materials, know where things are. So if you do run across a question that you're not quite sure of, you'll know where to find the possible answer. Okay? Maybe it's something you remember seeing in a textbook. Maybe it's something you remember doing as part of an exam. That will be of great help. The final's on sections 7 through 10, so pretty much object-oriented programming from there on. It's not supposed to be comprehensive, but some of the material that we talked about in the first 6 chapters could show up as functions, methods, while loops, if statements, etc. Quiz 4 will be just multiple choice true false, but the final will be more essay questions, short answers. No true false or multiple choice though. You'll have to write sentences, you'll have to look at code snippets, you might have to provide a code snippet. All right. Quiz 4 is just like quizzes 1, 2, and 3. The final is very similar to the midterm. So if you're unsure of what that looks like, go back and look at those other quizzes in the midterm. What I will do is the assignments must be turned in by the 11th. The 13th your quiz will be done. I think it's the 16th or 17th for the final. All of the dates are inside Canvas. Once that's done, I will begin totaling all the scores. And typically what I'll do is I'll put a letter grade in a column in the gradebook. Now that letter grade will be what I'm going to submit to SIS when I submit the final version of the grades. Because we don't have pluses and minuses at GCC, sometimes you can be very close to the next level grade, but you might fall short by a few points if we look just at average. So what I'll do is I'll look, see how close you are, look at your test scores, look at your assignments, how involved were you in class, did you not do discussion questions? Well, that's a problem. Did you just have one bad test? Well, that would lead me to believe that maybe the higher grade is warranted. I usually wait a couple days from then before I submit them to Canvas, or excuse me, to SIS, just because I want you guys to look everything over, make sure I've graded everything you've submitted. One year I transposed a student's, I think, exam from a 93 to a 39, which made a huge difference in a very good student score. So you want to look for those. I can have typos just as well as the next person does. So what I want to do now is talk about each one of the tests to give you an idea of what's being covered. So let's start with a Quiz 4 first. Again, this is on sections 9 and 10 in the book. It's going to consist of, looks like 30 questions or 20 questions. Hold on, I need to bring it up. It's going to be 20 questions, 3 points each. Obviously, since this is a chapter which is heavily steeped in exception handling and processing, you need to know the runtime errors. Divide by 0. Trying to get at a array entry which is out of a subscript range. Trying to use a letter when you're doing a calculation. Understand what try, catch, processing does. Now, if you're using a Python example, it's not try, catch, it's try, except. But that's fundamentally the same. The try section of your logic is going to be listening for any exceptions, and then you're going to outline the exceptions you expect to see in the exception blocks. The big advantage of having this try, catch processing inside your program is that if a person does fat finger an entry, and instead of putting $12, puts $$12, $$12 is a string. You can't do calculations with a string. So if you're not testing for that, and it tries to go into calculation, you're going to get a runtime error. So what you'd want to do is kind of plan in advance, get inside that user's head and think of all the things they can do to break your program, and make sure you have an appropriate catch block so you can process that error, give them a message, and have them continue. I think the last thing anybody wants to do is do all their holiday shopping on Amazon maybe typo a zip code and have the thing crash and start over again. You want your programs to take runtime errors and process them just like you would any kind of data input validation. As far as the GUI apps, how is your logic actually launched? Well, logic in GUI is launched with events on controls, sometimes called widgets. And these are things like buttons, text boxes, pull-down menus, radio buttons, checkboxes. Runtime exceptions and try-catch processing, it's what's sometimes misleading is it seems like it's only available with GUI applications, but it's not. You can have try-catch processing inside console applications, like Python. If you ran some of the Python examples, you probably saw that. You want to know what each one of the primary GUI widgets or controls are. What a label is. How is a label different than a text box or an entry control? How is it different than text area? What's the difference between a checkbox and a radio button, sometimes called option button? And if you review the textbook and look at some of the examples, I don't think that should be a problem. The only thing you got to remember is that just because you're used to seeing it, you've also got to know what it does. For example, if you're going to have a part of your application ask for a person's size, that's likely to be a radio button because they only can have one size. Whereas if you're asking that person to select pizza toppings, then you'd want to have more than one topping selected, or the potential for more than one topping selected, so that would be a checkbox. Radio buttons and option buttons, they're the same thing, are basically mutually exclusive. Only one can be selected, and that's important to remember. Also remember that labels, even though they hold text, are text that cannot be edited. A label is probably useful as a header, but obviously not useful for capturing information because it can't be edited. Know about some of the common events, click events, change events, hover event. We didn't do this extensively because really this is the kind of topic that comes up more in a programming language class. But we know enough of them and there's enough on this question, so you should be able to understand what the correct answer is. What's the object dictionary? You had to do an object dictionary for assignment 10. It's basically isolating all of those different widgets or controls and all of their properties and all their events, because each one of those widgets is actually a class object, which is why we cover class objects just before we do GUIs. One of the things, too, you want to understand is that GUI applications, even though they're easier to use, they're harder to design. Because what you have to do as a programmer is you have to get inside the user's head and figure out what they might do to break your application. If you create a GUI application where certain fields or buttons have to be clicked in a certain order, and if they're clicked out of order, it'll break, well, then you've got to make sure that your program is smart enough to know what options should be made available to the user, because sooner or later somebody will do something you never expected and cause it to break. Whereas a console application, since they're just answering prompts, is much more controlled. As the programmer, you can kind of dictate what's going to happen next. So even though GUI programs are easier to use, they're sometimes harder to program. Let's see what else we have here. Exception handling, mutual exclusive. Know what mutually exclusive is. That's something very useful to know with option radio buttons. Know that try-catch statements really help you mostly with the processing of logic. Don't have much of an impact on syntax errors. Syntax errors are typos. Let's see. Here's some common events. Single click, double click, drag and drop, change, mouse over, hover, click on. Let's see what else here. Know what a typical runtime exception is. In the classic, and whenever anybody asks you this question in whatever programming class you're taking, if they want to know what a runtime error is, you say divide by 0. If you don't think that's a problem, try it on your phone. You can't compute it. Let's see, what else we got here? Oh, properties. Properties can sometimes be important widgets too, especially if you want to disable or hide a widget until you need to use it. For example, going back to that little scenario I talked about a minute ago where the person was supposed to click on button 1, button 2, button 3, then what you might want to do is have button 1 enabled and have button 2 and 3 disabled until button 2 is clicked. And then maybe you want to disable 1 and 3 so that the only option they have is really button 2. And that's done through properties, of which are data items in a class object. Let's see. There's also a question about tkinter here. Tkinter is basically a framework that's a popular one. It's used primarily with Python, but it's also available for some other languages. But all languages have this ability to take and give you reusable class objects that are widgets, controls, text boxes, command buttons, whatever. No matter what language you use, Visual Basic, Java, Python, you name it. Most of the time, especially nowadays, it's included as a part of the language. Sometimes it has to be switched on. Sometimes different options exist in the form of frameworks, and they would be downloaded. And that's not necessarily a question. That's more of an FYI. That pretty much covers the quiz. 20 questions, 3 points each. The final, let me go to that. This actually has 60 points like the quiz is, but let me see how the question breakdown is. I think most of them are 5 points. Are they all 5 points? They appear to be all 5 points. So each question is 5 points, and what I do with these questions is you'll get partial credit. If there's a deduction, if you look in the notes box, you'll get an indication of why I deducted things. First question, how do you implement encapsulation? Well, public and private, public data variables, private data, public interface. The public interface would be get and set methods that allow you to change the private data inside the class. This makes the code much more reusable across multiple applications by different programmers. Abstract classes. An abstract class is a class that has one or more of the methods that is not fully defined. Therefore, it can't be instantiated. It can only be inherited. And the inherited version, or the child version of that inheritance, would implement that particular method. So I think the example I use quite often is there's used to be in the old days a designation you got when you had good grades called Dean's List. And if you had above a 3.5, you made the Dean's List, an economic honor, if you will. Well, some schools had lower numbers, 3.4, some higher, 3.6. So rather than in your class file implementing it to be a specific number, you could create a Dean's List method that's empty. And then when the person uses that for whatever school they're talking about, they would kind of fill in that part that would determine what the Dean's List number would be, whether it be 3.4, 3.6. Their logic would indicate that. So you can't ever use an abstract class because it's not complete, but you can inherit one. You can only inherit one. Think about object-oriented programs. Are they smaller, faster, more complex? What's the benefit? You want to think reuse here. Exception handling runtime errors right out of the Quiz4. What's an event? Right out of Quiz4. Polymorphism. That wasn't on the quiz, but, well, it wasn't in this quiz. It would have been the one Quiz 3, perhaps. Polymorphism is something which is found in class objects. It's when you have a method that has the same name but a different number of input parameters or different type of input parameters. Excuse me. Like, for example, the calculation of area. Area is length times width. But most languages support numbers as being integers, decimals. So is it 2 decimals, 2 integer decimal, or decimal integer? All of those numbers would work, so you would have 4 different versions of the same method, which is the same name, but what you would have as input is 4 different varieties. One for 2 integers, one for 2 decimals, one for decimal integer, and one for integer decimal. The other form of polymorphism is called overriding. Overloading is when you have different methods. Overriding is when you take a method that you inherited from your parent and you change it. Now, I just talked about abstraction, where we deliberately left the body of the method blank. This would be a scenario where the method was filled in, but you wanted to change the parent's version of it to your own version. So you put a new version in your child. That's called overriding. Here's a question on try, catch, and exception processing right out of Quiz4. Here's another one that asks the difference between a console and an event-driven application. Which is harder? What are the benefits? What do you have to be careful of when you're doing each one of these? And again, keep in mind that with a console application, you control the flow of the program. With a GUI, the user does. They can click anywhere they want. Excuse me. Know what an accessor and a mutator method is. Accessors get, mutators set. Know how it's important to encapsulation. Know how to, if you're going to have an inheritance situation where you're inheriting from a parent, how would you call out the parent's public interface to update its instance variable, maybe its name? You're still going to use the set name, but you're going to use the object variable that points to the child. And we have some examples of that in the textbook and also class examples. And lastly, this is the trick question, the hardest one in the whole test. What was your favorite topic covered in this class? What was the hardest topic covered in this class? Yes, it's worth 5 points. It's my holiday gift. I always do this. So anyways, that's a review of both the quiz and the test. Don't panic. I think that, it shouldn't be a surprise to anyone. There shouldn't be any sudden turns here. They should look like previous quizzes in the midterm. Take your time. Don't read too much into the question. Keep in mind that this is a level 1 class. It's not rocket science yet. If you give me a rocket science answer, make sure it still answers the fundamental question I'm answering. I enjoyed working with all you guys. Have a safe holiday, a happy break, and if you have any questions, let me know with a Canvas email. Take care.